Can I detect the movement of magnetic north? They say magnetic north is moving rapidly. Can I detect this from western North Carolina? It is moving about 60 kilometers a year. It is moving from the Canada side of the Arctic Ocean to the Siberian side. It might be like this on a map. What would this look like from eastern United States? The geometry indicates that of this 60 kilometers, we will see about 22 kilometers. I'm making that assumption, and furthermore, assuming that magnetic north is 6,000 kilometers away. Can I detect this movement from my basement using a huge magnetic needle, a mirror on a magnetic needle, and a laser beam for big amplification? The structure is made entirely of wood and glue. It is quite stable. The needle is also made of wood and glue. It has 450 grams of very strong neodymium magnets. They are clamped onto the wooden structure. The magnets are perfect. North and south are not on the ends, but on the faces. The needle is suspended with a string. The mirror is a special front surface mirror. It is sort of clamped onto the needle such that the angle can be adjusted and then secured. There is no iron or steel anywhere. I had a laser that was designed for landscaping and started with that. Then I realized that it was perfect for my project. I rewired it such that the switch is completely separate. I need to be able to turn it on and off without touching it. It is important that the foundation of the project is correct. This could be called diligence, using the words of a manager I used to work for. There's no demand for perfection, but I need to have confidence. To this end, I made a working practice rotor. It is like proof of concept. I should be able to make calculations and then confirm them with the substitute rotor. This little wooden guide takes the place of the magnetic needle in a fairly exact way. The academics are all about angles, distance, and radius. This practice needle has a careful mark at 11 centimeters. This set screw is calibrated such that the distance can be controlled with the turns. One turn is 1 millimeter to within 5% linear distance. There are lots of assumptions, but physicists do that all the time. 1 millimeter at 11 centimeters is how many centimeters at 450 centimeters? That's about 15 feet away. I should be able to calculate this and then experimentally demonstrate it. This would make a nice confirmation that I am not completely crazy. The laser signal has to hit perpendicular to the detector surface. That's for sure. This is all about the sine function in trigonometry. Sine is opposite over hypotenuse. The hypotenuse is the distance away, and the opposite is the deviation. Can I see the deviation represented by a year's movement? The angle is 22 divided by 6,000. So the angle with the sine of this quotient is the angle I must detect. I go to Google and ask, 0.0037 is the sine of what angle? It gives me stuff I do not understand, but some terminology. I try this. Arc sine, 0.00367, and it gives me 0.00367 radians. So the arc sine is the radians. Okay. Radians. Okay. Moving forward, I find arc sine of 0.00366 equals angle in degrees 0.21 degrees. So this is a fifth of a degree. What would this angle look like at 15 feet? That's 450 centimeters. I come up with 17 millimeters, about 2/3 of an inch. I'm pretty familiar with Arduino. The regular LED is about 1/8 of an inch diameter. The Arduino Mega Board has 30 inputs. Can this 17 millimeters be detected with 30 Boolean inputs? And maybe.